So we're going to look at descriptive statistics for ungrouped data. And when you're given data that is scattered like this here, we have been asked to develop what is called a frequency distribution data set for this. So the first thing you need to do is to identify the highest and the smallest number here. What is our highest number here? High value minus low value. You find the range in short. Then you divide it by the number of what? Classes, denoted by the letter K that you've been given. So you've been told to have how many classes? Six classes. So that's our K. All right. Then the largest number here is what? 48. That is the highest value. The lowest value here is what? 26. So let's find the range. What is 48 minus 26 divided by K? K is the number of classes, which is 6. What do we get? So we get 3.667. So this is what we call our class width. Is 3.67. So to the nearest, our class width here will be what? 4. So we've been asked to develop a class width starting with the number 25. So 25, we're going to use the class width. So this is 25 plus the class width is supposed to be what? 4. But if it's inclusive, if we want to add this, we add a minus 1. So this will be, we just add plus 3 there. So this is 25 to what? 25, 26, 27, 28, 29. Okay. So the class width okay, so we can say our class width is what? 4, 25 to 29. Then we go to 29 to, we added 4. What are we getting there? What are we getting there?
33.
Mr. Collins, on the range, don't we start with 25 itself? Is it supposed to be 25 to 28, 25, 26, 28? Or maybe the, I don't know.
So the class width is 4. So the numbers we're considering here are 25, 26, 27, and 28. The 29 is for the other part there. So don't count 29 there. If you want, would have done 25 to 28, 29 to 30 what? To 32. Then 33 to 36, 37. You get what I'm trying to say?
Yes, I am.
Yeah. Then we got what? 37 to what? 41. Then 41 to 45. Then 45 to 49. Okay, so let's count from 25 to 28. How many are they? From 25 to 28, how many are they? One, you can count them. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 here. Fortunately, they're arranged in order already. So here we have 8. Then from 29 to 32, how many are they? And 9 to 32, how many are they? 1, 2, 3, 4, 5, 6, 7, 6, 7, 8, 9, 10, 11. So it goes there. There, 11. Are we together? Is anyone lost? Then 33 to 37, how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Do you include the 37 itself? No. This is 33 to what? 36, all right? To 36. Let's count. How many are they? 33 to 36. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we cross there, we have 13. So put 13 there. Then when we go to 37 to 40, 37 to 40, how many are they? 1, 2, 3, 4, 5, 6, 7. So that's 7. Put 7 there.
Mr. Collins, the previous numbers are 12, not 13. From 13 to 30, I think they're 12.
Are you sure?
Yes.
From 33 to 36. Let's count again. 33 to 36. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, 13. All right. Then from 41 to 45, there was 0. 45 to 49, we have 1. So in total up there, our total is how many? Total is how many? There are 40. 1, 2, 3, 4, and 10 there. So it should be 40. A quick recap. What did we first do? How did we identify the classes? So we looked at the highest value and the lowest value. You get the range. You subtract the highest minus the lowest value and divide it by the number of classes you've been given, which is 6. We got 3.66. So the nearest is 4. So this is the class width. So this class width is going to guide us on how many classes we're going to have. 1, 2, 3, 4, 5, 6. They need to tally. 1, 2, 3, 4, 5, 6. So this is how you identify our number of classes we're going to get. Then you start counting because the frequency for the class width is 4. So how many numbers are there? Inclusiveness 25, 26, 27, and 28. All right. So these are 4 and the 28. We just added 29 because it is overlapping. This number is for this category. So where is 29, don't add it. If you wanted to have ended at 28, but it will mean we are going to do a plus minus 0.5 on the boundaries, which you don't want to now go through. So if you're going to use this one, it'll be a quicker way of drawing the histogram. You cut here to tell that you're not starting from, not to scale from here to there. You're going to do what? 25, 29. Just consider the error. 33, 37, 41, 45, and 49. So here, you can use your own scale. Just identify the highest number here. It is 12. So you can use 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12, and what? 14. So here, this one will go to 8, 8 is somewhere there. Here, this one will go to 11, 11 somewhere there. This one will go to 13, somewhere there. Then we'll go to 7, so it's somewhere there. Then will be 0, and this one will go to 1. So this is 8, 11, 13, 7, 0, and 1. Then you also need to ensure that you give the title, all right? Frequency and the class interval. Frequency, class interval. And the title is what? A histogram. Is that clear? Anyone behind so far?
So far, so good.
So far, so good.
Colin, so such questions, can they ask us to find the variance and standard deviation?
For the group data, yes, it's possible. But this was from your test. It was as far as this.
Okay.
Okay, any one behind so far? Are we there yet? Okay,
Yes, we are.
so let's now go to part B. What was part B asking for? We have an exam whose score for 10 students was what? 85. So our n is what? 10. Our summation of x was what? 85. But we're told that one of the students dropped. So meaning our n minus 1 becomes what? 9. The average changed to 90. So the average score for 10 students, this was the mean one. So the mean 2 was what? 90. So I want to know the score of the one who dropped. This is a very interesting question. Let's digest it together. Let me copy it to the word clip. I need you to think objectively. So what are we told in here? We're told that the average score for 10 students. So the data set that we have as follows. Okay. So we're told that sample 1, the students were 10. And their mean was what? X bar for sample 1 was what? 85. Don't know, we can calculate the summation of x. And for sample 2, they were how many? Were 9. The mean was now what? 90. All right, we can calculate the summation of x for the second one. So far, the way I've tabulated the information, are we together so far?
Yes, we are.
Okay, so we now need to know the formula for the mean is given by what? Summation of x over n. So here our mean was what? 85. Our summation of x, we don't know. Getting it, but we know that the sample size was 10. So meaning the summation of x for the mean to be 85 should have been 850. All right. Similarly, the mean 2, it's the same formula, except that we're changing the suffix. So here we're going to have 90 is equal to summation of x over what? 9 in this case. So here we have what? Summation of x for this one was what? 810. So far we're together.
Yes, we are.
So the difference here will be a score for the student who dropped out of class. So what's the difference there? 40.
Collins, I've got a question.
Uh-huh.
How did we get the 810?
10. Can somebody help us?
We multiplied the 90 by the 9.
So 90 times 9.
Oh, okay.
Okay. The score of what? Drop out was what? 40. So 4 marks for that. Is that clear?
So the X bar there, it's not a mean for it to be 85.
It's a mean. So for them to be 9 here.
And I'm lost on this page.
So mean is the average. So we are told that the mean for 9 pupils was 85. So I want to find out the total score for these 10 pupils. Sorry. The mean for 10 pupils was what? 85. So I want to find the score of this pupil. So we just multiply 10 times 85. So meaning these 10 pupils in total scored 850 scores. Now we're told that out of this 850, one of them dropped. We don't know his score, but after he dropped, the mean changed to 90. So we calculate to say, okay, the mean for the 9 students that remained was 90. So let's know the total score. The total score, when you multiply this by that one, is 810. So to find the difference for the person who dropped out, we get the total score for the 10 students and the total score for the 9 students. Then the remainder will obviously be for the one who dropped out. Is that clear now?
Yes, it is.
All right. Anyone behind? All right, so this is what this was all about. Okay, so we go to our next question here, where we're given the following. Okay, so we're told that the following is what? The data. We need to identify, construct a distribution for the data set and find the mode. So a frequency distribution is drawn as follows. The values that we have of X that are there and how many they are appearing. So we have the numbers in the distribution that we have are what? We have a 1, we have a 2, we have a 3. So ones, we have just 1. Twos, we just have one. Threes, we just have one. Fours, we have one, two, three. So the fours, we have three. The fives, we have one, two, three. The fives, we have three. So to draw the frequency distribution, 1, 2, 3, 4, 5. This is 1, 1, 1. Here we have 3. The fives are 3. So as simple as that, this is how you draw the frequency distribution. We also put the total there. That's our total. We have 1, 2, 3, 6, 9. All right, so this is how you draw the frequency distribution. Any questions at this point? Then you've been asked to identify, so this is 3 marks. Identify the mode. Which one is the mode? Which one is the mode? So mode is what? 4 and 5. It's a bimodal frequency. There are 2 modes here, 4 and 5. If they're all appearing once, there would be no mode. That one is straightforward. Is there anyone behind? Right. We go to question number D. Question number D. So, question number D, we're given 20 observations. We're given 20 observations. Now, in these 20 observations, we have been told to find the center of the 10th tip. So we need to rearrange them in order, starting from the smallest. We need to rearrange them in order, starting from the smallest. Okay. After we arrange them in order, we identify the rank of the 10 quasar tip. So what do we do in this case? Who wants to try? After we rearrange, what do we do? After we rearrange, what do we do? Let me arrange it quickly for you in the interest of time. Okay, so part D, the order of observations, we've rearranged them up to 20. Then we have the ordered observations from the smallest to the biggest. And the total observations are 20. So we need to rank the 10th tip. So tip number 10 is where? It's here. So to calculate the percentage, it's a 4th position over 20. So 4th position, when we calculate it as a percentage, so 4 over 20 will give you the 20th percentile, 20%. We're together. Any questions so far? I hope we're together. Can I proceed? So if they had asked you to calculate the 14 quarter tip in terms of percentile. So 14 quarter is on the 13th position. So you just do 13 out of 20 times 100. So to calculate the percentile, this would be what? 60. Okay, 65%. So in short, is to find the percentage of the order after rearranging them. Is that clear? All right, so we keep moving.
Yeah.
I hope we are progressing. We're progressing. So we go to our next question, which is question number E. Question number E, we're told we've been given the following information. Suppose you are in charge of rationing in a province affected by food shortage. You have been given the following table. Area A has a mean and the standard deviation of that. Area B, a standard deviation of that. All right. All right, together. So we have been asked to, we're also told that the estimated requirement of an adult is taken as 2,500 calories daily and the minimum absolute is 1350. Comment on the figures that we have. Okay, so here firstly, we need to know how to calculate what is called the coefficient of variation. Coefficient of variation is simply given as follows: the standard deviation over the mean times 100. Standard deviation over the mean times 100. So give me the CV for each of them. Quickly calculate that. The coefficient of variation for each of them.
A is 16.
A 16. B.
B is 10.
B is 10. Okay. Are you following what she's doing?
Yes, sir.
Okay. So what do you make of the 16 and the 10? Which one has a higher coefficient of variation?
A.
A. So what is the implication of having a higher coefficient of variation? What does this mean? I think I taught this some time back. What does it mean? When you have a higher coefficient of variation. I explained this quickly. What does this mean?
Unfortunately, for some of us, we didn't attend that class.
Those that attended, what does this mean? Please don't embarrass me. I taught this very clearly. When you have a higher coefficient of variation, what is the implication? Okay. So we've been given our area of A and area of B. Then we've been given our mean and our standard deviation. CV, we say it is given by standard deviation over the mean, 100, right? Then we had our mean for A be 2500 and 2000 here. Then here we have 400 and 200. What did you find here? What did you find? What was the coefficient of variation there? We divide 400 divided by 400 divided by 2500. What did you get?
We get 16.
10%. Then here 200 divided by 2000. What did you get?
We found 10.
10. So what comment could we have? Area B needs urgent attention because the mean or the average of the caloric value of the food available per adult during the current period in area B is less compared to the estimated of an adult. Then area B has a standard deviation of 200, so which may be less than 200 or more than 200. If less than 200, then minus 200 here, we're going to get 1800. So still is not closer to 2800, which is the normal. So if more than 200, then it will be 2200 when you add there. So it's still not close to the 2800. So area B needs more attention. So considering area A, the mean is 2500 and the standard deviation is what? 400. If the deviation is less than by 400, we're just subtracting 2500 minus 400. So it means it needs more attention. But if it's more by 100, which goes to about 2900 based on the 2800, so which is larger than the estimated. So area A needs not to worry compared to area B. So you can also comment in terms of the coefficient of variation. We've been given a benchmark of 2800. That is a normal in terms of calories that an adult must have. So after a survey was conducted, the mean that was scored by area A was 2500 plus minus what? The variation of 400. So when you subtract here, we're going to get a lower bound of 2100 and the upper bound of 2900. Then here we're going to have a lower bound of 1800 and the upper bound of 200. However, the expected range, which is optimal for an adult, is supposed to be 2800. So this one is low on the lower bound, but on the upper bound is higher. Even the coefficient of variation is higher than that of what? B. So meaning the one that needs more attention is area B because operating below the required standard, below the par. All right. So we go to question 2, which we've already done. So we'll end here for now, so that we prepare for our next class. Thank you so much for your attention. Have a good afternoon. Unless any burning questions.